Hello everyone, welcome back to our YouTube channel Let's Grow. I hope you are very well and doing great in your life. So today's topic of discussion is canal fall and its types. So in this video we will discuss about the canal fall and we will see that what are the various types of canal fall. So in the beginning we will initially see that what is a canal fall. So to understand this, let us see this example here. So this is your ground slope, correct? And this canal fall is a solid machinery structure which is constructed on the canal if the natural ground slope is steeper than the designed channel bed slope, correct? So this is your ground slope and your this blue color line shows the ground slope and this red color line shows the designed canal bed slope, correct? So here you can easily see that your ground slope is much more steeper than the designed canal bed slope, correct? So in these cases where your ground slope is much more steeper than the designed channel bed slope, we will provide the canal falls, correct? So in this case we will provide the drop in the elevation at a certain locations. So these drops in the canal or the fall in the canal is called as the canal fall, correct? And the another way is like this is your designed canal bed slope, correct? So if the elevation difference is not much more higher, then you can counterbalance this elevation difference by proposing a canal bed slope like this, correct? This is the proposed canal bed slope. So this proposed canal bed slope, it's same as your designed canal bed slope because these two green and red line are parallel, correct? So these both are the same slope. But if you provide the green color line slope, what you can see easily that this is your ground slope. So in this area, in this zone, there is a excess soil, correct? So here is a soil, this is the excess soil. So this soil you can use for the filling in this zone, correct? Because this is your ground zone, correct? This is your ground slope and here the soil is in excess and in this zone there is a deficiency of soil, there is no soil, so correct? So you can excavate this much amount of soil from here and you can fill this soil here, correct? So this is how by excavation and filling you can counterbalance the slope difference if the slope difference is less, correct? But if the slope difference is quite high, you need to provide the sudden drop in the canal bed. If the difference in slope is smaller, a single fall can be constructed, and if it is of higher, then falls are constructed at regular suitable intervals, correct? So if the slope difference is small, you can provide a single fall, correct? And if the slope difference is higher, then obviously you have to provide the number of falls at the suitable intervals, correct? So here you can see that in the upstream the water level is higher and there is a drop, correct? So this drop is in stepwise manner, correct? So small drop here, then water will flow, then a small drop here, then again water will flow, correct? So the in stepwise manner the falls are provided, correct? So now there are a number of types of canal falls which depends upon various aspects of the ground. So we will discuss one by one these types of falls here, correct? So we will discuss about the Ogee falls, rapid canal falls, stepped falls, trapezoidal notch falls, well type falls, simple vertical drop falls, straight glacis falls, Montague type falls, and English falls, which is also known as baffle falls, correct? So initially we will discuss about the Ogee falls, correct? So this is the Ogee falls. So in this Ogee fall you can clearly see that it is a combination of convex and concave surface, correct? So here you can see the convex and concave both surfaces, correct? So this Ogee fall is the combination of convex and concave surfaces, correct? And why these surfaces are provided? Basically these surfaces are helpful for the smooth transition of flow, correct, and hence reduce the impact. So water will flow over this surface and this will easily move your water over the surface, so the transition of flow can take place easily, correct? And if this canal natural ground surface is suddenly changed to the steeper slope, then this Ogee fall is recommended for that canal, correct? So if your ground surface is like this, correct, if the canal natural ground surface is suddenly changed to steeper slope, correct, this is the general slope, and suddenly the slope of the canal becomes steeper, correct? So in this case we will provide the Ogee falls, correct? So here you can see this rubble machinery as well. This rubble machinery is provided, and again this surface is finished or smoothened with the cement mortar. Stone pitching is provided in the downstream side as well as on the upstream side, correct? And this falls Ogee fall structure with stand over the concrete bed, and this is the concrete vertical wall, correct? So this is the Ogee falls. So you need to remember that Ogee falls contain convex and concave both surfaces, and this Ogee fall is recommended when the canal natural ground surface slope is suddenly changed to the steeper slope. Now the second one is the rapid canal falls, correct? So this rapid canal fall consists of a long sloping glacis, correct? So here in this image you can see this long sloping glacis, correct? And this type of canal falls are constructed if the available natural ground surface is plain and long, correct? So if your ground surface is plain and long enough, in that case you will provide the rapid canal falls, correct? And these rapid falls are high priced construction, correct? So the price involved in this type of structure is quite high, because you need to construct the structure in a large area, correct? So this is a long glacis, correct? So you need to construct this structure in lengthwise manner in a good length. So the cost involved in the construction of this structure is quite high. This is the bed of the rapid falls, correct? So this is the rapid fall structure, and you keep remember that these type of canal falls are constructed if the available natural ground surface is plain and long enough. Now then the another one type of fall is stepped canal falls, correct? So here name itself suggests that there are a number of steps, like you can see in this image the steps, first step, then second step, then third step, fourth step, and the fifth step. So water will fall downstream in the stepwise manner. So these are the drops, first drop, then second drop, then third drop. So water will flow in a drop wise manner, correct? And the rubber machinery is provided, and these drops are constructed with the brick wall, correct? So basically in the name itself we can see that these consist of the vertical steps, correct, at the gradual intervals. And if we can see it is a modification of the rapid fall, correct? In rapid falls we will provide a slope, correct? But in this stepped falls we are providing the slope in stepwise manner. So it is the modification of rapid falls, and these type of falls are suitable for the canal which has it upstream at very high level as compared to downstream. Correct. So if the elevation difference between the upstream and the downstream is quite high, in that case we will provide the stepped type of canal falls. Correct. So you need to remember only this thing, that if the difference in elevation between the upstream of the canal and downstream of canal is quite high, then this elevation difference is counterbalanced using the stepped falls, where the elevation difference is counterbalanced using the number of stepped which is provided in the stepped falls. Now the another one type of fall is the trapezoidal notch fall. Correct. So in this trapezoidal notch fall, a high crested wall is built across the channel. Correct. So this is your channel and the high crest wall is provided. Correct. So this is your crest wall which is provided in the upstream across the channel, and in this type of crest wall we provide the trapezoidal notches. Correct. So here you can see the number of trapezoidal channels which is provided here, 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 here and here. So in this crest wall a number of trapezoidal channels are provided. Correct. And these type of structures are very economical, and these are mostly suitable for the low discharges. Correct. If the discharge is low, and in only that cases we will provide the trapezoidal notch falls. Correct. And if we look in the current scenarios, these type of structures are widely used because of their simplicity. So this is all about the trapezoidal notch falls. The things you can remember, that these trapezoidal notch falls are provided for the low discharges, and they are quite easy to simple. That is why they are very popular. Correct. And in this we are having the high crest wall, and in that crest wall we provide the trapezoidal notches as the name suggests. Okay. So you can remember all of these things. Now the next one is the well type falls. Correct. So these well type falls are also known as the siphon drop falls. Correct. So as the name suggests, siphon means the siphonic action will come into picture. Correct. So in this type of structure we generally provide an inlet well at the bottom of the upstream, and a pipe is connected to it which convey the water in the downstream, either in the reservoir or well. Correct. So here you can see, this is the image. The water will come from here. Correct. And it will flow through the pipe. Correct. And it will go into the downstream. So these are the structure. Correct. So this is your cement concrete. Correct. This is your cement concrete, bed of cement concrete over which this well type canal falls will stand. Correct. And this is the dry stone pitching, and water will simply come here and water will go through a pipe. Correct. Pipe or well, and it will be come in the reservoir. If reservoir is there in downstream, it will directly go into the reservoir. Otherwise it will go into the downstream well. Okay. So this is the well type falls. Another one is the simple vertical drop falls. Correct. This is very popular, and this simple vertical drop falls are also known as Sarda type falls. Correct. These are also called as Sarda type falls, and in this you can easily see that there is a single vertical drop. Correct. Which allows the upstream water to fall with sudden impact on the downstream. So there is a vertical wall, concrete or machinery wall, and water will flow over which from the upstream to the downstream, and there is a sudden impact in the downstream. Correct. So this downstream act like a cushion. correct, for the upstream water and dissipate the extra energy, correct. So this water cushion will be here, and this water cushion will help to dissipate the extra energy which is coming from the upstream. So due to this impact on this water cushion, whatever extra energy is having, that extra energy will dissipate in the downstream, correct. And these type of falls is initially tried in the Sarda canal, which is situated in UP, India, and that is why it is called as the Sarda Falls, correct. So why it is called as the Sarda Falls? Because these type of falls are initially constructed in the Sarda canal, which is situated in UP, and it is a simple vertical drop falls, correct. So it is all about this. Now the another one is the straight glacis falls, correct. And this is the modern type of construction, in which what we will do, we will provide a raised crest, means we will increase the height of crest across the canal, and we will provide a inclined surface from the raised crest to the downstream, and the water will come from the upstream and it will cross the raised crest and falls on the inclined surface with the sufficient energy dissipation, correct. So this is the upstream of the canal, this is upstream of canal. So in this upstream we will provide a raised crest, correct. So here we have provide the raised crest, we have increased the crest height, and water will start to accumulate in the upstream, and once the water will overflow, it will go through the straight inclined surface. This is the straight inclined surface, and thus water will come into the downstream, correct. So this is the straight glacis force, and the sufficient energy dissipation will took place on the inclined surface itself. So there will be no erosion in the downstream, correct. So this is all about the straight glacis canal falls. Now the next one is the Montague type falls, correct. Montague type falls. So this Montague type fall is similar to the straight glacis, correct. But the only difference is that in case of the straight glacis, the profile will be straight. It is similar as a line, correct. But in the Montague type canal falls, these glacis are not straight. It is provided in the parabolic profile, correct. So here you can see the parabolic profile, correct. So this is the parabolic profile, and these parabolic profiles are provided in Montague type fall. And why this parabolic profile is introduced? Because it is provided because if the profile is parabolic, there will be a vertical component of velocity as well, correct. If there is a which depends upon the angle of inclination. So if there is a vertical component of the velocity, which improves the energy dissipation to some extent, correct. So if the water will, if there is a vertical drop, there will be a only down the velocity component will be in downward direction alone. But if the profile is parabolic, there is a vertical component, of velocity, and this vertical component of velocity will be helpful to some extent to dissipate the energy in a better way. So that is why these parabolic profiles are preferred in this Montague type falls, correct. And this is the, I think, last one type of fall, which is a English or baffle canal falls, correct. So in this case, what we will do, so in this case the straight glacis fall is extended as a baffle platform with the baffle wall, and here you can see a baffle wall, correct. Why this baffle wall is provided? This baffle wall is provided to create the hydraulic jump, correct. And through the hydraulic jump, the extra energy will be dissipated, correct. And it is suitable for any of the discharge, correct? Irrespective of the discharge, whether the discharge is high, medium or low, you can construct these type of English or baffle falls, correct? So there is no limitation for the discharge like we have in the trapezoidal type of notch, trapezoidal notch canal falls, in which it is preferred only for low discharges. And this baffle wall is constructed near the toe. This is the toe and it is constructed near the toe at the required distance in the designed height, whatever height is required to formulate a hydraulic jump, which depends upon the discharge. And I told you the purpose, that why it is created. It is just because for the to create the hydraulic jump, correct? So this is the profile wall, brick pitching, upstream bed, downstream bed, all these things you can see here, correct? So this is all about the canal falls. I hope you like this video. If you have watched this video till the end, make sure you like it, you can share it with your friends. Thank you so much to watch this lesson till the end. Happy learnings with the let's grow. Thank you so much again to watch this video till the end. Okay, take care, bye bye.